Hi guys, so in this video I'm going to be talking about calculus. Truth of the matter is this is one aspect of mathematics. Mathematics has several aspects and or several branches, if I may say. There is algebra, there's geometry, there's statistics, and there's also calculus. So calculus is one aspect of mathematics, and it's one aspect that most people really are scared of or are afraid of. Most people fear. Now, for one reason or the other, which I cannot fathom generally, but the truth of the matter is actually an interesting and easy topic. Actually, it is not that difficult, I promise you. It is not. Most of the fears that has happened is as a result of maybe hearsay and just perception. So I'll try to break a few concepts down in this video to show you that it's not really as difficult as it is. So this calculus, let's get right to it, is divided into two again. Now the calculus is likely to a father that has two children. That the younger son is known as differentiation, or you can call it differential calculus, and the older son is known as integration, or you can call it integral calculus. Now the differentiation is, I call it the younger son, to why integration is the older son, simply because you need to understand integration, you need to understand differentiation a bit. My goal in this video is to actually talk about integration, but knowing very well that you need to know a bit of differentiation before integration. So I'll try to just give a preamble on differentiation. Now, differentiation, let's look at it. This is what we call, under differentiation, we have the general rule. Now, this general rule, suppose y is equals to ax raised to power n. Now, dy, now dx is simply nax n minus 1. Now, truth of the matter is this is simply the general rule for differentiation. Why do I call this general rule? Because this simple formula applies to most aspects of differentiation and even some aspects of integration. Now, y is equals to ax raised to power n, dy dx is nax n minus 1. When I differentiate this, n times a x n minus 1. Now, the reason why most people are scared of this particular course is because of y dy dx. But truth of the matter is, dy dx is simply just a letter. This dy dx is pronounced as dy dx. It is the letter that is there against the letter that is there. Meaning that if I have f here and this is g raised to power n, this will be simply df dg. Do you understand? So it is dy dx is simply because in mathematics generally the two most used letters are x and y. So it is y against x. So don't be scared about that aspect. So if I have y is equals to ax raised to power n, now an example, y is equals to, say, s squared. Now, maybe 5s squared. Dy dx, this is y as against x. To differentiate this, I'm going to say, I will compare this with this. Now, a is simply what now? When you compare it, a is 5 and my n is 2. Now, when I look at what I've done here, this is na. So this is 2 multiplied by what? By 5. So 2 times 5x, this is n minus 1, 2 minus 1. So 2 times 5 is what? 10. X, 2 minus 1 is 1. So dy dx is what? 10x. And simply, I've just differentiated this question. It's as easy as that. Now, another example, suppose I have y is equals to 7x raised to power 3 plus 2x raised to power 2 minus 3x plus 9. Now what I'm simply going to do here, I'm going to differentiate each of them following this same principle here. Now compare this with this particular one that I've done before. NA means A is 7 and my N is what? 3. So it will now be NA, that's 3 multiplied by 7 x, that's 3 minus 1 plus 2. Compare this with this. A is 2 and N is 2. 2 multiplied by 2 x, 2 minus 1 minus, now compare this with this. Now my A is 3, my N here is 1, not 0. X raised to power 1 is still x. So 1 times 3 x, 1 minus 1. Now don't forget I have 9. 9 is a constant, doesn't have any letter attached to it. Whenever you are differentiating a constant, it is 0. Please take note of that. If y is equals to c, dy dx is equals to 0. A constant gives 0 when differentiating. So when you differentiate a constant, you have 0. So 9 automatically is out. Now, so 3 times 7 is 21. X, 3 minus 1 is 2. Plus 2 times 2, 4. X, 2 minus 1 is 1. Minus 1 times 3, 3x, 1 minus 1 is 0. Now, but anything raised to power 0 is 1. So x raised to power 0 is 1 times 3, which is still 21x squared plus 4x minus 3. And this is dy dx. So I've simply just differentiated this question. It's as simple as that. And this is the general rule in differentiation. So this is differentiation. Now I'm going to now go to integration. Truth of the matter is this. If you look at these two brothers that I said earlier, differentiation and integration. Differentiation, even in English language, to differentiate means to separate something, and integration means to come together, to bring something together. To integrate something means to fuse something together. So they are like word and opposite. Just as you have it in English, you also have it in mathematics. In calculus, integration now is anti-differentiation. It's simply the opposite, or integration is anti-differentiation, or I call it the reverse of differentiation. And I will show you that. Now the general rule for integration is, if you have this ax n dx, is simply ax n plus 1 over n plus 1 plus c, or better still, or k. Some people may use k. So it's still the same. So integration is anti-differentiation, and this is the general rule for integration. Now, so what I'm simply going to do here is to now say, okay, using an example earlier, I'm going to say, now, to show you or to prove to you that integration is the opposite of differentiation, this particular question here that I have dy dx 10x, I'm going to simply integrate it, and then if I have this 10x dx, now this is the sign for integration, this thing, this long curve here. Now compare this with this. This is my ax raised to power n, now dx. My a is 10 here and my n is 1, so I will simply say 10x. now that will be what? Compare this. This is 1 raised to power 1, 1 plus 1 over 1 plus 1. Now when I do that, that is 10x. 1 plus 1 is 2, divide both sides by 2. So I have this. This is 2 can go in 10. This is 5x squared plus c. or like I said earlier, you can use k. So you can see I have 5x squared here, and this is 5x squared here. So this takes it back to the question originally. Once I differentiated 5x squared, I had 10x. When I integrated 10x, I had 5x squared back. So that's to tell you that integration is truly the reverse of differentiation. Now, one question that you may be having is why the c or the k, which represents constant? It's simply because earlier I told you that in differentiation, when you differentiate a constant is 0. Now, the reason why we put c when integrating is simply because if, for instance, I have 7x raised to power 4, if I differentiate and I have this 7 raised to power 4 plus, say, 419. Now, if I differentiate this, using my general rule here, I'm going to get 4 times 7, which is 28x, 4 minus 1, that's 3. Now, if I also differentiate this, I will have 28x raised to power 3. But when I differentiate this, it will give me 0. So, if you look at it now, there are two different answers, but the same, two different question actually, but the same answer. You have 7x4 and 7x4 plus 419. So, but one of them, you have 28x cubed and then you have 28x cubed. Both of them are actually the same answer, but one has 7x4 is a variable, one has a constant. So, because in integration, when you have a question, you don't really know which one is which, as a constant or not. So to make up for that imaginary constant, we call it arbitrarily. Whenever you integrate a question, you put plus c or plus k to assume that there is a constant there initially. That's it. So that's the essence of the c or the k. Now, I also told you that in differentiating earlier, a constant, if you differentiate a constant, 9 is 0. But what about if I was integrating a constant? Now, if I have 1 x, if I have 1 dx, now I want to integrate this one particularly. Now, this is a constant 1. What can I do? Knowing fully well that integral x raised to power 0 dx. If I can write this 1 as x raised to power 0 dx, meaning that integrate with respect to x. Now, this one is the same thing as this. Why? Because anything raised to power 0 is 1. So I have not really changed anything. You see the same question. So once I have it like this, I can now apply this principle of integration here that says ax n plus 1 over n plus 1. Comparing this with this, my a is my 1 because it's the number beside x, and my n is my 0. So it gives me x raised to power 0 plus 1 over 0 plus 1. So when I have this is x 1 over 1, which is still x. So you can see that when I integrate 1, I have x. And if I differentiate x, it gives me 1 back. You are right. So integration is anti-differentiation. So this is simply the basic of calculus. Now, so in subsequent videos, I'll be showing you other rules attached to differentiation, and also in integration, other types of integration. We have different types of integration. So, but this is the basic, and this is just what you need to know as far as calculus is concerned for the basic. If you are starting it for the first time, if you are new to it, this gives you a very good idea of what you should expect. So you can see I've not really used a calculator since I started. There's really no use for calculation, any calculator here, because it's pretty straightforward. Like I said earlier, this is a very interesting and yet very simple topic. So we've come to the end of this class. If you found this video useful, please do well to like it and subscribe. Also turn on the notification bell. That's very important so that you can be notified when I post subsequent videos concerning this topic, calculus, and other interesting topics. See you in the next video. Bye for now.